Hello, good day. Let's take a look at this integral. I say evaluate integral s raised to the power of 2x dx. Uh, Here, the appropriate techniques for uh, evaluating this integral is using integration by substitutions. Okay, here we will let x raised to the power of 2x is equal to u, or we say let u is equal to 2 raised to the power of s, so that the integral will be since u is or since s raised to the power of 2 is u, the integral will become u dx. Okay, we need to find a way around uh, to we need to find a substitution for the x. So here u is equal to s raised to the power of 2x. So to obtain the x, we will differentiate equation 1 applying logarithmic rules. Now, first of all, we take logarithm of both sides, take log of both sides, and if that is done, this comes ln u is equal to ln x raised to the power of 2x. So applying the law of logarithm, the power, which is 2x, has to be transformed back, and this will become ln u equals to 2x ln x. Okay, now we're going to differentiate with this with the respect of s. As you can see, this part on the right hand side is a product. Okay, so we're going to use the product rule. First, we hold ln x, then we differentiate to x, then plus we hold 2s and differentiate ln x. Okay, or we hold ln x and differentiate to x, then we hold 2x and differentiate ln x. However, then on this side, ln u is 1 over u. The derivative of ln is 1 over the function here. So here this becomes 1 over u times du dx is equal to ln x, then d dx of 2s plus 2x, then d dx of ln x. Okay, here, if that is done, here we got 1 over u times the u dx is equal to 2. If we differentiate 2x, it becomes 2 multiplied by ln s, this becomes 2 ln s plus, if we differentiate ln s is 1 over x times 2x. X here we go with x, so x we cancel h as, and this become 1 over u. The u dx is equal to 2 ln x plus 2. Okay, here we are trying to find an expression for the x. So for us to obtain that, we multiply both sides of this equation by the x over 2 ln x plus 2. Okay, so the essence is to take care of some values there. Okay, the essence is to take some of those variable within the function. So here you can see here the x will be off with the x will go off with the s. Okay, similarly 2 ln x plus 2 will also cancel 2 ln x plus 2. Okay, and if that is done, 2 ln x plus 2 will also go off with 2 ln s plus 2, so that the s is equal to the u all over u open bracket 2 ln x plus 2 close brackets. Okay, now if we bring in place of the s in this highlighted integral, so in place of the u we will substitute in place of the x, in place of the s, we substitute the u all over u open bracket 2 ln x plus 2. And here we have u will take care of u, and that will be off. U divide u, that will be off. then the integral, that is the the functions 2 ln x plus 2 is a constant in this aspect. So we need to factor it out so that this become 1 over 2 ln x plus 2 integral the u. Okay, remember, if you integrate the u, the value will also be what? Will be a u. Okay, so substituting here, this become 1 over 2 ln x plus 2 times u plus c, where c is usually an arbitrary constant. So you recall that we said initially that u is equal to s raised to the power of 2, and in place of u here we substitute that, so that the integral s square s raised to the power of 2x ds is equal to s raised to the power of 2s divide 2 ln x plus 2 plus an arbitrary constant. So this is how to find the integral of this. The best approach to this is to use integration by algebra substitutions. Please, if you like this video, help me hit the subscribe, hit the notification button, so that when this thing comes up next, you have access to them. Have a nice time. See you in my next virtual class.